All right. Everyone have a good weekend. My neighborhood had a scavenger hunt this weekend. So random objects from Halloween or Christmas or St. Patrick's Day or like beachy theme, just a crazy random object placed in somebody's yard, tree. There were like 52 houses that participated. So we walked around the neighborhood all day yesterday, making sure that we could find every single possible item that we could find because we won last year. And my daughter Sadie needed to win again this year. That there were two that we couldn't find. So hopefully nobody else found those other two because she's gonna be crushed. But we probably walked 6 miles yesterday. Just going back and forth, like trying to find it because we still couldn't find the falling water. And I didn't know what the falling water really meant. Was it a fountain or was it the falling water building by Frank Lloyd Wright? It was capitalized, so I thought it was the building, but maybe it was just water falling down a little fountain or something. So we'll see. Our entries were due by 5 yesterday and we got them in at like 4:45. Hopefully we win again. You got to keep up that like name that we won last year. You got to win this year. So that was our fun for yesterday. We had softball games all weekend as well, but yesterday at least was kind of getting some activity in the neighborhood. Coffee truck also in the neighborhood. Anybody have coffee trucks up here in your neighborhoods? No food trucks in the neighborhood?
Yeah, sometimes we have like a dog park. Well, we call it the dog park, but there's this like little like cute little like pavilion park thing, and they come there all the time. And they just park there sometimes.
Yeah, that's what it's kind of neat. I don't know. Every Friday? That's nice. Very neat. Yeah, that's cool. We like one of our neighbors owns a coffee truck, so it's the Urban Trails. It's a cute. It was like a horse trailer at one point, and they converted it into a coffee truck. It's really cute. So we get that every once in a while. I don't know why they only come every once in a while. I think they should be there every Saturday or Sunday. I mean, they're in the neighborhood, but I guess they have to go to other neighborhoods too.
I think that's the one that came on the other night. Isn't it?
Oh, yes, I think so. Yes. Yeah, it's a cute little trailer. Yes, I do think they were at Thon. Yes. How was Thon for those of you who were there?
It was fun.
Yeah.
It was raining and cold.
I know.
It was fun though.
It didn't rain, but it was still raining. Yeah, that's a bummer. All right. So on Friday, the lesson from Friday was on arithmetic and geometric sequences, which we talked about on Thursday. Arithmetic meaning adding or subtracting, geometric meaning multiplying to get to the next term. But the lesson was on writing the equation or the formula or the rule, depending on which word you want to use, to have that equation. So if it's arithmetic or geometric, there's a specific pattern that we can follow and a way we can write the formula for those sequences. So we're going to look more at that today. But today we're also going to look at finding out how many terms are in a sequence. So if it isn't an infinite sequence and it's finite, it has an ending, how many terms would be in that sequence? And then we're also going to look at the arithmetic and geometric mean. You actually talked about the geometric mean with triangles last year. So we're going to look at it with sequences a little bit. And then again, a worksheet today, pretty much all week you have a worksheet. I don't think there's bookwork until next week, but I think every day this week is a worksheet. Friday, there'll be tests on sequences. Next week, we'll talk about the series, which is a special kind of sequence. And then you'll have a test on series as well. And then we'll wrap up the year with probability and statistics kind of combined together. So I'm going to start in the notes. There is a page in your notes that has like a cute little bubble around it. And once this comes up here, show you what I'm talking about. We're going to start with the conclusion. It says give it a try. This is page 9. I thought we'd start here as like a warm up, and then we're actually just going to work backwards through the notes. But again, this is at the bottom of page 9 where it says give it a try. I thought we would do this as a nice little review summary from Friday. So number one gives us two sequences. It says identify if it's arithmetic or geometric, and then it says write the formula for the two sequences. So looking at the first one, 6, 1, -4, and -9, and then it continues on. So first, is it arithmetic or geometric? And how do you know, Jaden?
Arithmetic value is 5 every time you get
Yeah. So she said arithmetic, you're subtracting 5 every time to get to the next term. So for it to be arithmetic, adding or subtracting the same number each time. So that adding or subtracting value is the common difference. That is our D. And she said subtracting 5. So that means the common difference between one term to the next is -5. So you're asked to write an explicit formula. The explicit formula is taking the first term plus n-1 times the common difference. So Jaden, what is the first term if we're trying to write this formula? Yeah. So the n-5, that's our variable part. That's like the x. But in sequences, it's n. So it's going to stay as n-1. You're plugging in the first term and you're plugging in the common difference. And then if you simplify, you will have the formula for the sequence, or the rule for the sequence, the pattern for the sequence. So we have 6 minus 5n plus 5. So that means my sequence is -5n plus 11. And you can check it out. So if I plug a 1 in for the first term, I would get -5 plus 11, which makes 6. If I plug a 2 in to find the second term, I would have -10 plus 11, which makes 1. But that is a way that you can always find an equation or a formula for a sequence when it's arithmetic. Questions? So looking at the second one, 3, 6, 12, 24. Jordan, what do you notice about 3, 6, 12, 24? Yeah. So geometric, we are multiplying by 2. And when it's geometric, that's called the common ratio. What are you multiplying by to get from one number to the next? And not 2, she said 2, I wrote 3. Jordan, do you remember what that formula looks like?
A sub n equals the first term times the common ratio and then x.
Yeah. So it's written as an exponent when you're multiplying to get to the next number. Your n-1 is in the exponent location. So to write this formula, the first term is 3. The common ratio is 2. And then the exponent of that 2 is n-1. Now remember, this is an exponential number. You don't multiply 3 times 2 because 3 is just the integer 3. 2 is connected to an exponent, so it's an exponential value. They aren't the same. Numbers have to be the same in order for us to multiply them together. So you keep it as the 3, the first term, times 2, the exponent, and -1. Questions? All right, let's look at the next part here. It says find the 20th term of the geometric sequence. What's one way you could find the 20th term? Brooke? Yeah, So we can write out the formula and then plug in the number that we're looking for n. The other option would be to calculate all of them, which would kind of take a while to get all of them. And you might make a mistake accidentally doing the wrong thing to get to the next number. They could get pretty big as well. So Brooke, what are you doing to get from one term to the next term? Yeah. So it did say it's geometric. You're multiplying by -3. And she said, let's write the formula. So Jordan just said that the formula was the first term, which is -2, times the ratio, which is -3, and then n minus 1. So that's our formula. You're asked to find the 20th term. So what are you going to plug in for n? Brooke? Does yours say 12? Yeah, you'd plug in 20. So I want to find the 20th term. Whatever term I want to find is what you plug in for n. N represents the term you'd like to find, the term in the sequence. So -3 and then 20 minus 1. Probably need a calculator for this because you're taking -3 to the 19th power and then multiplying that by -2. You can plug it exactly how you have it written. You can plug it in your calculator. Good question. So you could take the -2 and then just use parentheses around the -3 and then the exponent of 19. So yeah, you can plug it in all in one step. No need to do separate parts. Good question. But it's going to be a big number. You're finding the 20th term. We're multiplying by -3. Ella, did you get a number? What'd you get? Pretty big number. And if you were trying to calculate that on your own, you would just keep taking that number and multiplying it by 3, taking the new number, multiplying it by -3. I'm sorry. I mean, it would be a lot of writing to do. It's a little quicker just plugging stuff into the formula. Any questions? So that was a little summary from Friday. As I said, I thought we would look at that first, just to give you a little refresher as to what went on Friday in class, finding those sequences and writing the formula for them. Are there questions on writing formulas for sequences? So we are going to go backwards and we're going to go to the bottom of page 8 and look at example 4. So on Friday, you did example 2 and 3, which were the word problems. One was arithmetic, one was geometric, showing you how a word problem worked. And then you had homework problems, which was on arithmetic and geometric sequences, writing formulas. And again, there were 2 word problems on that homework as well. So we're going to look at a couple of other types of examples or applications with these sequences. And example 4 wants you to find the number of terms in the sequence. Notice that this sequence is different than the others that we've looked at because it has an ending. So instead of it just saying 3, 9, 15, 21, ... it shows that it's ending at the number 177. That's the last number in this sequence. And the question is asking us to figure out how many terms are in this sequence. Are there 10? Are there 20? Are there 25? We want to figure out how many terms there would be. Now, obviously, you could list out all the terms and count them. I could just say whatever the pattern is, and I can continue the pattern until I get to the number 177, and then I could count all of them. That works. It might take a little longer. You might make more mistakes, but it definitely could be a way that you could approach the problem. Of course, there's a mathematical way to approach the problem as well, which is the way we're going to use instead of just kind of adding 6 each time or adding 5 each time or adding 4 each time. What do you think you could do mathematically for this sequence? to find the number of terms. So what's one thing that you notice about this sequence? 3, 6, 15, 21, 177. Is it arithmetic or geometric? Let's start with that. Riley, what do you think? And why is it arithmetic? Yeah. So if we're adding 6 and we say it's arithmetic, that means the D value is 6. So we can write a formula for this sequence and see if the formula can help us find the number of terms. So that formula says take the first term, add n minus 1, and then times 6. So we're going to see if we can create the formula and then use that formula to help us figure out how many terms are in the sequence. How many numbers would make this sequence? So it looks like we have 6n and then minus 3. So that is our formula or the rule for the sequence. Our goal is to figure out the number of terms. The n in the sequence represents the term. So let's go back to the last one that we just did. We want to define the 20th term. To find the 20th term, we plugged in a 20 in place of n to find the 20th term. So this sequence ends or has the 20th term of this huge number. N represents the term that you're trying to find. Or in this case, it's also telling us that this 20th term would be 20 numbers in my sequence. So if I go back to my problem here, N is going to represent that last term. How many terms are there in the sequence? What could you do with the number 177 to figure out what term that would be? Gabby? Yeah, and it is simple compared to everything that we've done. Holy cow, is that simple. So if you take the last number of the sequence and plug it in for A sub n, that represents the value of the sequence. The n will tell me the position that that value is in. And Gabby, if we solve this simple little equation, so 180 divided by 6, you said was, I'm sorry, 30 terms. I apologize. So 30 terms. So that means I could plug in 30 for n, and I should get 177. So my 170 or my 30th term is 177, or there are 30 terms in the sequence. So again, you could write them all out, but that's a lot of terms to write out. I mean, you have 5 up here, you've got to write 25 more. Really easy to make a mistake when you're doing that as well. Questions? So to find the number of terms, you take the last number, you plug it into what it's equal to, and you solve for n. N represents that term. What position is the term in? Questions on that? So the other thing I said we were going to find was something called the geometric mean. So the geometric mean, geometry, geo, they kind of go together. And there is a triangle, a pair of triangles that are created from the geometric mean. But the geometric mean takes values that are listed as a pattern. And I'm just going to use A, X, and B. So A would be the first number they give us. X is the value we're trying to find. And then B would be the second number. So the goal here is to find the X if this sequence is geometric. Geometric means I'm multiplying by something to get to the next term. So I have a 3. What would I multiply by then to get to that X and then multiply by that same number to get to 18? When you have a geometric sequence, the R that you're multiplying by represents the ratio. So remember, a geometric sequence has a common ratio. What are you multiplying by to get from one number to the next? How can you write a ratio? So how is a ratio written? It can be written 3 different ways. Ava? In fraction form. So we can write a ratio as a fraction. We could write it as a decimal. We could write it with a colon, like 3 to 5 would be a ratio. But we're going to write our ratio as a fraction. So the geometric mean says take the A value, the first number in the sequence, and write it as a ratio comparing it to the second number. That's going to be equal to the second number compared to the ratio of the third number. That's the geometric mean. So it's taking two ratios, comparing your first to the second, and then the second to the third, and setting them equal to each other as a proportion. So if we take 3 to x, which is the same as x over 18, we now have a proportion or a rational equation that we know how to solve for. Ava, how would you solve for this rational equation? Yeah, so x squared is equal to, what is 3 times 18? 54. And then you would square root both sides. And we have the square root of 54. Now, at this point, we're not going to get a decimal. We're keeping things exact. So what would you do with the square root of 54, Eva? What goes into 54? Yeah. Which we know is 3, and then the square root is 6. We also know that when you take a square root, what goes in front when you're solving for x squared? A plus or a minus sign. So this one's weird, but this is saying that your x should be 3 times the square root of 6, and it could be positive or it could be negative. So my sequence would say 3 root 6, and then 18. Or it could be 3 root 6, and then 18. The reason it could be positive or negative is because I could be multiplying by a positive number, or I could be multiplying by a negative number. And if you take a positive times a positive, you get a positive. But if you take a positive times a negative, then I could get that negative number. So that's called the geometric mean. I'm going to put a part B over here. Because there is an arithmetic mean. And that's the typical mean that you think of when you see the word mean, the average. So if I had that same sequence and I wanted to determine the value of x, and you're adding to get from one number to the next. When you're adding to get from one number to the next, you're truly finding the middle of the sequence. So if I wanted to find the middle of the sequence, because I'm adding the same number each time, I would take 3 plus 18 and just cut it in half. So what would my middle number be if it's an arithmetic sequence? What is 3 plus 18 divided by 2? Gabby? Say it again. 21 over 2. So I would have 3 21 halves and then 18. 21 halves is 10 and a half. That would be in the middle of 3 and 18. So you're trying to find the number in the middle of those two values. But is it in the middle because it's arithmetic, or is it in the middle because it's geometric? You have to solve them differently because one represents a ratio, where the other one just represents what are you adding to get to the next term. questions. So there is one other type of example that I would like to go over. And that is in the middle of the next slide where it says write a rule for the nth term of the sequence given the term and the common difference or the common ratio. So whenever it says write a rule, that's when you're trying to write a formula. You're trying to write a pattern. A sub n equals. So this one says write a rule for the nth term. Given a term in the sequence and the common ratio or the common difference. In part A, they're telling you that the 10th term is 30 and the difference is 7/2. So Grace, is this an arithmetic or a geometric sequence if they're giving you the difference? Yeah, this is arithmetic. So we know arithmetic means the first term plus n minus 1 times the common difference. Our goal is to write a rule for the nth term. And you're given that the 10th term is 30 and the common difference is 7/2. So think about it. How would you find a rule for this sequence? So I don't know what the numbers are in the sequence besides the 10th term is 30. But we do know that you're adding 7/2 to get from one number to the next. How do you think you would find a rule, Brooke? So she's saying the 10 goes in place of the n because they're telling us we have the 10th term. What else, Brooke, could we plug in? 7/2 for D. Yeah, your variable is a sub 1. We're going to try and find the first term. So we know the 10th term is 30. So 30 and the 10th term go together. So the sequence is going to be equal to 30 if I plug in a 10 for the 10th term. You're actually finding the first term of the sequence. So this is a linear equation where you're solving for a variable in the equation. Very algebraic. See if you can solve for the first term. So we're taking 9 times 7/2. I gave you an evil fraction to work with. So that's 63/2. 9 times 7 is 63 over 2. 30 is really 60/2. So I have 60 over 2 equals the first term plus 63 over 2. So what is the first term? Brooke? It's -3/2. That's where our sequence is going to start. So our first term is -3/2. Now the directions say to write the rule. So I now know the first term and we know the common difference. So this is a longer problem. To write the rule, I know the first term is -3/2. N minus 1. That now tells me I'm writing a rule because it has a variable n in it. And then times 7/2. So I would have 7/2 n minus 7/2. So if I combine my like terms, the first term was -7/2. My D, when I distribute that through, I also have a -7/2. I'm sorry, -3/2 and -7/2. That makes -10/2 or -5. So it was a two-part problem. We first had to know, what does the sequence start with? What's the first term? They give you the 10th term, but we need to know the first term to write a pattern or to write a rule or to write a formula. After you find that first term, then you still have to get the formula. So you knew the common difference. We found the first term, and then we could find the formula. That's an upper level question. That's an application. Can you take what you know, the algebra that you've learned throughout the year, and try and find that formula? So I am going to stop there because I want you to be able to take a peek at your homework. So your homework today contains problems with arithmetic and geometric sequences, writing rules for those sequences, finding the number of terms in the sequence, looking at some applications of those sequences. Of course, there is an answer sheet provided for you. This is also a nice summary sheet, kind of the sequences that we've been working with in the first handful of sections. So the first 4 problems are asking you to find the first 4 terms and then the 24th term. Please show some work. If you just have answers there, I have no clue how you're getting the answers besides just writing them from the answer key. I know we're at the end of the year, but by now the expectation should be that you know that you've got to show work for every problem. The second group of problems, I'm not sure why it says 3 through 6. It should say 5 through 8. Determine if the sequence is arithmetic, geometric, or neither, and then write the formula for the nth term. And then 2 problems dealing with finding the number of terms, and then 2 problems finding the x if it's a geometric sequence. And then the last one is another little word problem. So there are 12 problems, kind of summarizing the concepts that we've discussed. Tomorrow and Wednesday, we're going to go over one other type of pattern or rule called a recursive formula. These are called explicit. So we're going to talk about also writing a recursive formula tomorrow and Wednesday. And then we will review on Thursday for a sequence test on Friday. Questions? So find the first number of terms there. We got a couple of minutes to see if maybe you can get a couple of those problems done. 1, 2, maybe. Those are pretty